Geometric progression, GP. A geometric progression is a sequence in which any two consecutive times differ by a constant multiple or factor. It is also known as exponential sequence. Consider those geometric sequence 6, 8, 54, 162. Now this sequence is increasing, but it is increasing by a multiple, which is 3. 6 times 3 is 18, 18 times 3 is 54, 54 times 3 is 162. So the next term will be 162 times 3. So the common ratio is equals to 3. Consider this other example. 6 times 24, 36, 54, 81. Now, that sequence is also increasing, but it's increasing by the multiple of 1.5. 16 times 1.5 is 24. 24 times 1.5 is 36. 36 times 1.5 is 54. And 54 times 1.5 is 81. So the common ratio is equals to 1.5. Consider this other example. 20 minus 10, 5 minus 2 whole number 1 over 2, 1 whole number 1 over 4. This sequence is decreasing, but it's decreasing by a multiple of minus half. 20 times minus half is minus 10. 10 times minus half is 5. 5 times minus half is minus 1 over 1 over 2. And minus 1 over 1 over 2 times minus half is 1 over 1 over 4. It's kind of an alternative sequence though. R is equals to minus 1 over 2. So in a geometric progression, the numbers are either increasing or decreasing, but it is increasing by a multiple, a factor. Now, one thing we must understand in geometric progression is the common ratio. And the common ratio is given by the division of any two consecutive times. The common ratio is equals to the nth time divided by the nth minus 1 time. Hence, the common ratio is equals to the second time divided by the first time. Common ratio is equals to the third time divided by the second time. Common ratio is equals to the fourth time divided by the third time. Hence, the common ratio is the nth time divided by the nth minus 1 time. Now, let's talk about the times. In a geometric progression, the first time is equals to a. Second time is equals to a times the common ratio. The third term is equals to a times the common ratio square. The fourth time is equals to a common ratio q. The fifth time is equals to a times common ratio raised to power 4. So if we continue in this manner, we end up having that the nth time is equals to a common ratio n minus 1. If you observe, well, this is 4, yes, 5, 3, 4, 2, 1. So we just have to subtract 1 from the nth time to get the power of the common ratio, which we did. Yeah. So given time in a geometric progression is equals to a arrow n minus 1. And this is the general formula for geometric progression. Now let's take an example. Example 1. The first term of a geometric progression is 7, while the common ratio is 3. Find the 11th term. So from the question, the first term, which is a, is equals to 7. The common ratio arrow is equals to 3, where it has to find the 11th term. Now using the general formula for GP, we have that UN is equals to A arrow n minus 1. So U11 will be equals to A is 7 times arrow is 3 raised to power n here is 11 minus 1. So U11 is equals to 7 times 3 raised to power 10. And U11 is equals to 7 times 3 raised to power 10 is 59,049. And when we multiply 7 times this figure, we have 413,343. So this is the 11th time of the GP. Example 2. The 8th time of a GP is 640. If the first time is 5, find the common ratio and the 10th time. So let's solve this problem. In the problem, we are told that the 8th time is equals to 640. The first time is equals to 5. So we has to find the common ratio. We also has to find the 10th time. Now, using the general formula that UN is equals to A arrow n minus 1, then let's solve with this first information here. That U8 is equals to A is 5. We don't know what arrow is now. Raised to power n minus 1. N here is 8, which is 8 minus 1. Now U8 is equals to 640. So 640 is equals to 5 arrow raised to power 7. At this point, we divide both sides by 5. So all over 5, all over 5. 5 will cancel 5. 5 into 640 is 128. 128 is equals to arrow raised to power 7. Now what should we do next to get 7? We are going to raise both sides to the power of 1 over 7. So this will be 128 raised to the power 1 over 7 is equals to arrow raised to the power of 7 times 1 over 7. So we'll actually raise both sides to the power of 1 over 7. And the reason for 8 is 1 over 7 times 7 is equals to 1. So as here is 8, we'll raise both sides to 1 over 8. So at this point, 7 cancels 7. We are left here with arrow. So arrow is equals to 128 raised to the power 1 over 7. So if we decide to solve this, what will be the answer? So I believe we can use the calculator here. So it is 128 raised to the power of 1 over 7. The answer is 2. 128 raised to the power 1 over 2. 128 raised to the power of 1 over 7 is 2. So let's go back. Let's imply that arrow is equals to 2. So we can write that arrow is equals to 2. So we find our common ratio and it's 2. Now let's find the 10th term of the sequence. So far, the first term is equals to 5. The common ratio is equals to 2. Now we're looking for the 10th term. Now recall that UN is equals to a arrow n minus 1. So u10 will be equals to a is 5 times 2 raised to the power n, n is 10 minus 1. So u10 is equals to 5 times 2 raised to the power 9. u10 is equals to 5 times 2 raised to the power 9. That will give us 512. 2 raised to the power 9 is 512. So u10 is equals to 5 times 512. That is 2560. And that is the answer. So the answer is 2560. Example 3. Example 3. The total of the night time of a JP are 54 and 39,366 respectively. Find the system, sum of the fourth and the seventh term, and the product of the second and the fifth term. So from the question, the third term is equals to 54. The ninth term is equals to 39,366. Now we're looking for the system in here. But before we can find any of the time, first of all need to find the common ratio and the first term. And we can do that from the information given so far. Now let's work with the first information here, that the third term is equals to 54. Now recall that un in a GP is equals to a arrow n minus 1. So u3 is equals to a arrow 3 minus 1. And u3 is 54, so this is 54 is equals to a arrow square. Now let this be equation 1. Now let's work with the other information. That the night time is equals to 39,366. Now un is equals to a arrow n minus 1. Then u9 is equals to a arrow 9 minus 1. u9 is 39,366, and this gives us a arrow raised to the power 8. Now let's call this equation 2. From equation 1, (54) is equals to a arrow square. We can make a the subject of the formula. If we do so, we divide both sides by arrow square. Then arrow square cancel arrow square. A becomes 54 over arrow square. That is equation 3. We're going to substitute equation 3 into equation 2. Recall that equation 2, which is 39,366, is equals to a arrow raised to the power 8. Now substituting equation 3 into equation 2, we have 39,366 is equals to a. A is equals to 54 over arrow square. So it becomes 54 over arrow square times arrow raised to the power 8. So at this point, we have 39,366 is equals to 54 times arrow raised to the power 8 minus 2. Here's an indices. So this, we are going to subtract the power of arrow. So if we proceed, we have 39,366 is equals to 54 arrow raised to the power 6. Now to get arrow, we need to divide both sides by 54. So 54 cancels 54 here. 39,366 divided by 54 is 7 129, and this gives us r raised to the power 6. Now, to get r, we need to raise both sides to the power of 1 over 6. So if I raise this part to 1 over 6, this 1 over 6 will eliminate the 6. So the same with this side, raised to the power of 1 over 6. Hence, 1 over 6 will cancel 6 here. Here we're left with r. So now 729 raised to the power 1 over 6. We can just use our calculator to get that. 729 raised to the power of 1 over 6. The answer is 3. So let's go back. 729 raised to the power 1 over 6 is 3. So therefore, r is equals to 3. So we're able to find r. But from equation 3, a is equals to 54 divided by r squared. So a is equals to 54 all over r is 3 square. A is equals to 54 over 9. A is equals to 6. So therefore, r is equals to 3 and a is equals to 6. Now with these two information, we'll be able to find any times of our choice. Now the a part of the question is we should find the 6th time. Now, since a is equals to 6 and r is equals to 3, recall that un is equals to a r n minus 1. So u6 is equals to 6 times 3, which is ar raised to power 6. The nth time is 6 minus 1. So u6 is equals to 6 times 3 raised to power 5. u6 is equals to 6 times 3 raised to power 5, that is 243. u6 is equals to 6 times 243, that will give us 1458. So the B part of the question is we should find the 4th time plus the 7th time. Now a remains 6 and r remains 3. un is equals to a r n minus 1. So u4 is equals to 6 times 3, 4 minus 1. u4 is equals to 6 times 3 raised to power 3. u4 is equals to 6 times 27. u4 is equals to 162. We also need to find u7. Now recall that un is equals to a r n minus 1. So u7 will be equals to a is 6 times r is 3, 7 years n minus 1. u7 is equals to 6 times 3 raised to power 6. u7 is equals to 6 times 3 raised to power 6 is 729. So u7 will be equals to 4,374. Now recall that the B part of the question was we should find the 4th time plus the 7th time. Now the 4th time is 162 plus the 7th time is 4,374. Now when we add them up, we have 4,536 as the answer. So that's the B part of the question. Let's move over to the C part of the question. In the C part of the question, we are asked to find the product of the 2nd time and the 5th time. Now, recall that r is equals to 3 and a is equals to 6. So for the 2nd time, un is equals to a r n minus 1. So u2 is equals to a is 6 times 3, 2 minus 1. So u2 is equals to 6 times 3 raised to power 1. u2 is equals to 6 times 3, that is 18. So in the same way, we need to find u5. Since un is equals to a arrow n minus 1, so u5 is equals to a, which is 6 times 3, 5 minus 1. u5 is equals to 6 times 3 raised to the power 4, and u5 is equals to 6 times 3 raised to the power 4. That is 81, and u5 is equals to 486. The cell part of the question was to find the product of the second time times the fifth time, and this is 18 times 486. If you multiply these two numbers together, the answer is 8,748, and that is the answer. Let's consider one more example, example 4. The following gives a geometric sequence: 2p, q, 250. Find the value of p and q. Okay, so from the question, the sequence given was 2p, q, and 250. We have to find the value of p and q. So what do we have here? We have that the first time is equals to 2, the second time a arrow is equals to p, the third time a arrow square is equals to q, the fourth time a arrow q is equals to 250. So from this first equation and the last equation, we'll be able to find r. Now look at the last equation here, which is a arrow q is equals to 250. Now what is a? From the first time, a is 2. So 2 arrow q is equals to 250. Now we divide both sides by 2. We have arrow q is equals to 125. We have that arrow q is equals to 125. What can we do next? For us to eliminate its power, we need to multiply both sides with the power of 1 over 3. So this is arrows per 3 times 1 over 3 is equals to 125 raised to power 1 over 3. So 3 will cancel 3, we're left with arrow here is equals to 125 raised to power 1 over 3 is 125 raised to the power of 1 over 3. The answer is 5. 5 is the answer. So the common ratio is 5. If we decide to go back, we have that a arrow is equals to p. So p is equals to a arrow. Hence p is equals to a is 2 and arrow is 5. So 2 times 5, and that will give us 10. P is equals to 10. So what about q? Q is equals to a arrow square. So q is equals to a arrow square. Q is equals to a is 2 and arrow is 5 square. So q is equals to 2 times 25. Q is equals to 50. And that is the answer. So at this point, if you want to learn more about geometric progression, just message me directly on WhatsApp. Meanwhile, subscribe to my channel, share and like this video. I will see you in my next video.